So how is this going to work in terms of graphing? Well, we just graphed them on their basic sense. But I'm just going to use sine as an example. So all of our trig functions are basically going to be of this form. So f of x is equal to d plus a times sine of b times x plus e. Alright, so d plus a times sine, or cosine, or tangent, of b of x plus e. Alright, so first, what I'm saying here is that you just need to treat this like a regular function. So, let me draw some real lines now. So, trick of the trade. You don't actually have to do anything different. You can graph the function the same way that you would any other day. The only thing that really changes is the labels. Now, some professors don't like this, but you know what? In my book, it's accurate. So it works. So again, I'm going to use yellow here. 0, 1, 0, -1, and 1. Okay, so we're graphing. Now, I actually already made a mistake here. This thing, that's not actually 1 and -1. That's the amplitude. So this is how much we're scaling it. If the original function scaled by 1, so from -1 to 1, and so now we're scaling on the outside of the function, that means the outputs are going to go from -a to a, because we're just taking a and multiplying it by the two extremes, which are -1 and 1. So I'm going to put a -a and an a. Okay, so what else? Well, what about this thing? What about this d? Well, you're just adding d to everything. So, okay, so that's really over here, d plus a, d minus a, and then the central point is going to be d. Alright, well that's not so bad. But again, like I've said in the past, doing things to the function itself typically a lot nicer than doing things inside the function. So, how does this work? Well, again, if you take this inside these here, remember what I said just a couple minutes ago? If you want to look at this, you want to factor out a b. So what happens if you factor out a b? Well, this becomes c over b. Alright? So this is b times quantity x plus c over b. Okay, this is where it starts to get fun. The period, or the scaling of the x-axis, is a b here. But remember, because we're dealing with something inside the function, we're not actually multiplying the period or the length of the function by b, we're dividing by b. So that means instead of this point out here being 2 pi, it's going to be 2 pi over b. Okay? It's going to be 2 pi over b. In the same sense, instead of this being 0, here in the x direction, it's actually going to be, what's this again? C over b. But again, we're shifting the coordinate system to the right, effectively moving the function to the left. So this is going to be negative c over b. So what you get over here is this is 2 pi over b minus c over b. Okay? And then you can figure out the ones in the middle. And this is true for sine, this is true for cosine. It's a little bit trickier with tangent, but I'm sure you can figure that out. Again, feel free to rewind the video and take a look at what I was saying here. So the general form of a trig function like this that's been transferred is f of x is equal to d plus a times sine of b times x plus c.